Again, welcome to Java Programming Language. This is Introduction to Programs and Java lectures. In these lectures, we're going to cover the basic concept of computer programming language and also Java. We're also going to describe the relationship between Java and the World Wide Web. Also, we are going to understand the concept or the meaning of Java language specification, such as API. API stands for Application Program Interface, which is normally consists of Java library files that we can use in our program. JDK stands for Java Development Kit. This is also a platform or Java library files that we use to again run our program Java code. Normally we run the Java source code, which will be interpreted to machine language so that our CPU understand. Again, we know Java is a higher level language. So most of the source code looks like English language, which the computer doesn't understand. Computer only understand binary numeric system, which is the machine language. Also, IDE stands for Integrated Development Environment. This is the platform also we use to again run our Java source code. And this will be a GUI, graphical user interface. So IDE normally is integrated development environment, which means it consists of text editor that we are going to use to write our source code. And also it consists of the interpreter, which will again convert or translate our source code to machine language. And also it consists of debugger to again debug our program and run it, testing, etc. So why Java? That's the first question. Now, to answer this question, we will say that Java enable users to develop and also deploy application on the internet for servers, desktop computers, small handheld devices. We know the internet is our future computing or technology in terms of IT, computing, networking, whereby we may have thousands, if not millions of computers communicating with each other, World Wide Web. So the internet drive IT or computing to next level, which increase the demand of it. So Java play a very pivotal role in this section because Java also is an internet programming language. Since we know the internet consists of millions of different computer platforms, architectures, and Java is a neutral, platform neutral. So which means Java supports any computer platform or architecture. So this is why again Java is very good for internet programming language. So Java, web, and beyond. We see also that Java can be used to develop standalone application. We can also use Java to develop application running from the browser, or the web applications. We can use Java to develop web applications. These will be applications that runs online on the internet or from a browser. Also, Java can be used to develop application for on-end devices, such as our mobile devices and smartphone. This is again hand-held devices. So Java also can be used to develop application for web servers. Normally, web servers provide services to most clients online or on the internet. So we can see that Java play a very pivotal role in internet technology or computation. So we have a short Java history here. Java started in 1995. It was developed in a company named the Sun World or Sun Microsystem. First, it was called Hook, and later the name was changed to Java. And then from there, we have the first Hot Java. This is the first enabled web browser. And also, to get the earlier history, more details in Java, I will urge you to go to the link here, the website here, which gives us more details. So what are the characteristics of Java? First, Java is a simple language. So Java is partially modeled on C++, but greatly simplified and improved. A very good example is that C++ supports again multiple inheritance, which means one class can inherit more than one class. So let's say that we use the term a base class and a derived class or the superclass and subclass. So a superclass would be the parent class and the subclass would be the child class. In Java, the subclass can inherit only one parent class, not more than one. So Java doesn't support multiple inheritance. This is one of the features that make Java more simple comparing to C++. So C++, again, is more complicated than Java. Also, Java is an object-oriented programming from start. So the first time we write our Java code, we are going to have a main class, a class. So for example, in C++ or C, we may start with structuring program with no class. Then after maybe we finish some of the concept like loops, decision, statement, etc., then we may introduce object-oriented. So we can write a very powerful C or C++ code or program without using object-oriented concept. But with Java, it's not so. In Java, the first, even if you want to write a program, only one statement, welcome to Java, to print on your screen. You still have to create a main class. And inside this main class, we are going to have the main method. That's if it's a standalone program. And if it's applet or other programs, still we need a class. We may discuss that more detail in the future lectures. So Java also is a distributed concept. It uses a distributed computing. Distributed computing means a computing system that involves several computers working together on a network, and that's a distributed system. So Java is designed to make distributed computing easy. That's why Java again is very good for internet programming. Internet programming is a distributed computing system. So since the network is capability is inherently integrated into Java, writing a network program is like sending and receiving data to and from a file. Also, Java is interpreted language. So this makes Java a little bit slower than C++. C++ is compile. The difference between interpreted language and then compiling is that when you are interpreting, we write the source code, and when we interpret it means one statement at a time will be converted to machine language. But with C++, all the code will be converted at once. That's compiler will translate everything to the machine code at once. So again, this makes Java a little bit slower. And also Java have a machine called the Java Virtual Machine Code. This is the code that will convert the Java source code to bytecode, then from there to machine language. So this is the concept that make Java platform neutral. Any computer architecture, whether a desktop computer or a mainframe or a tablet, mobile devices, as far as the computer have a Java virtual machine code, it can again run in a Java language or it can run in a Java program. So the bytecode is the machine independent and can run on any machine that have a Java interpreter. Also, Java is robust. We say Java compilers can detect many problems that will first show up at execution time in other languages. So it will show up again in earlier stages. And Java has eliminated certain types of error-prone programming constructs which are found in other languages. And Java also has a runtime exception handling feature that provide programming support for robustness. So again, Java is very robust. Also, Java is very secure compared to other programming language. Java implements several security mechanisms to protect your system against harm caused by strange programs. And since Java runs a lot in internet platform, again, we know the internet consists of thousands, if not millions of computers. So security is a very big issue. Also, Java is architectural neutral. As we said earlier, Java Virtual Machine make it possible for Java to be run in almost any computer architecture, from mainframe to smartphone. And Java is also portable. Since Java is architectural neutral, it means Java programs are portable. They can be run on any platform without being recompiled again, such as C++ or C language. And Java performance is very good compared to most programming language. Now, because again, Java is architectural neutral, Java programs are portable, so they can run on a platform without being recompiled. And also, Java have a multi-threading system. So multi-threading programming is smoothly integrated in Java, whereas other language have to call procedures specific for the operating system to handle the multi-threading. Multi-threading means more or less like a multitasking. We can write two threads, or a thread means a small code, segment of a code, and both can run simultaneously. Also, Java is dynamic. Java was designed to adapt to an evolving environment. So new code can be loaded on the fly without recompilation. Also, there's no need for developers to create or for users to install major new software versions. So new features can be incorporated transparently as needed. And this makes, again, Java a dynamic programming language. Also, Java have three types of editions. We have the Java Standard Edition. This normally will be supported a client standalone application or applets. So a client-side standalone application can be the desktop computer. And then we have the Java Enterprise Edition, which normally will support the server-side and large computers like medium size or large size of servers. Normally in networking systems, servers are computers that provide service to the client, and client will be the desktop or the user's desk computers. And normally they request services from the server. So we have another type of Java, like Java servlets. These are programs that run on the web servers or server machines. Also, we have a Java server pages and Java server faces. So standard edition, I would say, is the medium size, client size. The enterprise edition, again, will be the large size of computers. And then the Java micro edition will be the smallest devices, such as a smartphone, a tablet, mobile devices I will use. So these are the two most popular Java IDEs, and we are going to use the Eclipse or NetBeans in this course. Those are the two major Java IDEs or integrated development environment. So this is a very simple Java program. Let's say we use a notepad or a test pad, and we can write our code. Again, we may go details on this in the future lectures. But when we look at this program, what will be printed? This is a console application. And what will be printed, or what this program is doing, is to print the message, "Welcome to Java." Welcome to Java is a string because it's on double quotation. So with Java, this is my standalone program. Always we start with our main class. So that's why we say Java is an object-oriented program from the beginning. This is one of the first programs we will see most of the time in any Java textbook. Writing a program to print only one sentences or one word on the screen. That's the most basic, only one statement we have. If we have less than one statement, then the program doing nothing. So here we have a double slash we are saying here, which is the backward slash means comment. So when we compile this program or interpret or run it, everything after the comment sign, which is the two backward slash, will not be printed or affect the IDE program. So here we just have and this will be a comment. This program print welcome to Java. So we are explaining what this program will do. Now from public, the keyword public going, this is our Java code now. So later on, we're going to explain, we have three types of access. We call these access specifiers. Access specifiers. We are public, private, and protected. Public means any program, classes, or any entity in the program can easily access everything here. But normally in our main class, we always make it public because we have a main method which doesn't depend on any object, again, or any class. We may discuss this detail. Now, when you have a method that have a keyword static or static, it means that method is a standalone method. I may use that term, which means this method doesn't have any class. Now, later on, we are going to create a class, a user-defined class. When we create our own, let's say we create a class named employee, and I have a method named calculate salary. I need to create an object first. Then I'll use the object with a period and the method name to access it or to use it. So a static method means it doesn't rely on any class or any object. So always we start with the keyword public class. Now the file name will be called welcome. So the name of the main class is the same as the name of the file. And also Java extension, file name extension is also Java. So here I'm going to call this, the name of this file will be welcome.java. So the operating system knows that this is a Java file. So we have a public, static, void. Void means this method is not expecting any returning value. And the name of the main method is also called main. Then we have a string array with arguments. So system.out.println is to print an item on the screen. In this case, it will be console, or more or less a black screen like DOS. So println is a method that will print something on our screen. LN means when we print finish, the cursor will move to a new line. So we say that LN stands for new line. Print means to print. Then the system.out will be the concept of the class where the print ln method belongs. Again, we may go more detail on this, which we have a class for it. So for example, if I run this program, I'm going to click welcome. We have some platform here, so we can see our code here. So this is now the Java code. We remove the comment. So here we have public, class, welcome. All the keywords. Keywords means the words that the Java IDE or the interpreter understand. So they are blue. So public class and void, these are keywords. We cannot use these words in any naming of Java, either the variable, method, class, etc., because they are reserved. Keywords are the reserved words, which is understood by the Java IDE or the interpreter. So we have the public static void, the name main, the argument. Then here we say system.out.println. So if I run this program, I'm going to compile run at the same time here. And you see my output down. It says, welcome to Java. The compile successful, which means our program runs successful, and we print welcome to Java. So later on, we are going to fill in some code to again have more advanced program. But right now, this is our first Java program, which is a program that is only, again, doing one thing, printing welcome to Java in our screen. So again, system.out.println is to print something on a black screen does. This is a console application. So if we are using Notepad, we are going to enter our source file, then we save it and make sure the extension is .java, so welcome.java. Then we have to locate the directory where we save it. So in this case, we save it in our Notepad, which is in a book folder, and the name is welcome to Java. Then now we have to use the compiler, which we normally use C. If we are using, again, the IDE, is very straightforward. So IDE means we have the GUI. So let's go forward one more time. Okay, we don't have it here, but again, we have IDE means everything is the menu. Again, we'll see it in a few slides to come. But this is a DOS prompt. We change the convention. Then to compile it, we use the Java C and the name of the file. Then to run it, we use Java, the keyword Java to run it. So here we are assuming we create the file using a WordPad. We save it, welcome.java, because the main class name is welcome. And this is the process of doing it. So first, we are going to create and modify the source code if possible. So this is the source code again, public class welcome, public static void main, system.out.println, print welcome to Java. So the first step, we write the source code, we save it in our computer. Then, as I said earlier, to compile our program, this is using the command-driven interface like DOS. We use the command Java C together, Java C. So Java C space welcome.java means I'm compiling the programming language called Java and welcome to Java. So after we compile it, finish, and there was no error. So here we can see everything is 0, no error. And then we have a bytecode now. So we have to use it to run. To run, we use the keyword Java. So Java welcome with no file extension, because we are running the bytecode now. So the bytecode will give us what we need, our output. So the output will be welcome to Java. That's the result. So it's like 2 steps: create your source code, then we compile and run it. When you compile, if there's any syntax error or any error, we can continue. But if we have what we call the logical error means the syntax error is grammatical error. So logical error means we don't have no syntax error. The grammatical error for the language is correct. For example, in Java, we end a statement with semicolon. If I remove this semicolon, I may have a grammatical error, which is the syntax error. So if we don't have no syntax error, we can have what we call the logical error. For example, I want, excuse me. For example, I want to multiply 2 numbers, but I'm going to divide it. So the answer will be different. So that one is very hard to see. We need to test our program with some input and look at our result. If it's correct or wrong, then we can also test it. Again, we may go detail on all this. Our first goal here is how to run our first programming language. Java language. So as we said earlier, this is our main method. Then we have our first statement. Actually, that's the only statement, system.out.println. We are going to print welcome to Java. So when we run it, we get our output welcome to Java. Now we have another program, welcome, with 3 messages. So let's see how we can write 3 messages. So the only thing here is that we are repeating the same thing 3 times. So first we have system.out.println, we print our first message. Second, we have the same system.out.println to print our second message. Then thirdly, we have again. Now, if I want to print 100 messages, well, I don't want to use system.out.println 100 times. So in this case, we are going to use a loop, or we say a repetition statement, make it possible to do something over and over and over and again. We may discuss this again in our future lectures. So if I run this program, I should get 3 messages printed. And this is the output at the bottom. Here we have program is fun, fundamentals first, and problem driven. You can see that we have the 3 statements in 3 different lines because we are using println. Now, if we use system.out.print alone, then we will see that everything will be printed on 1 statement. And we may discuss this more in detail also. So anytime we are compiling and running program using the command prompt, first thing we need to do, we need to set up the path or the directory where our file is located. In this case, the Java JDK library files that have all the possible files to translate or interpret source code to, again, bytecode. Then we can set a class to include the current set class path. After we set it finished, now the compiler can see our file. So they are in the same directory, the same folder or directory. Then we use the command javac to compile. Then when we want to run it, we use only Java. Now, if you are using IDEs such as a test pad here, then everything is going. So I write my source code, I'll save it using the GUIN, and then the file name extension.java. Then if I want to run it also, I'll use the menu, then run it. And we may do this again in the future. So again, this will be the conclusion of our second lectures in Java, and wish everybody the best. Thank you.